to AutoCAD 3D Lectures with your instructor Ilya Gindis. We are now in Chapter 4 and the first lesson, and here we're going to introduce solid modeling and curve design. With this chapter, we head into a new direction and begin talking about some of the advanced solid modeling tools that make up what can be referred to as curved design. While these tools are not necessarily more difficult to master, they do open up a new range of modeling possibilities, including some rather complex 3D designs. We are going to introduce revolve, shell, taper, loft, path extrusion, and sweep over a series of 3 lessons. Now, to go over the environment briefly, well, we don't have anything new here really. We have the same 3D modeling ribbon on top, toolbars, no new ones, no old ones taken away, and of course the cascading menus and the command line, and the units are in architectural. So make sure your screen matches. Alright, the first command we're going to cover is revolve. As essential as extrude was to flat design, such is the importance of revolve to curve design. And it's the first command we're going to cover. Revolve easily creates complex revolved shapes based on the concept of solid of revolution or surface of revolution. And this command has no other equivalent in AutoCAD. The basic idea is as following. We would like to draw a 2D outline of an object and revolve this outline or profile around an axis. If the profile is closed, the result is a solid of revolution. If the profile is open, has gaps, or lines are used instead of polylines, the result is a surface of revolution. This process can create some unique shapes that are impossible to make any other way, but the entire concept rests on the designer's ability to visualize the profile on which the model is built. Now, in past releases of AutoCAD, the revolve command was a bit picky, and you had to use a closed polyline for the command to work, no exceptions. These restrictions have been lifted, and you can create a profile using a regular line command and even leave gaps in it, although once again, just be aware that this creates surfaces, not solids. And we're going to show that later. Your axis of revolution could be anywhere, on or near the object, and you need not revolve all the way around, but can use any degree value in between if necessary, such as when you want to show a cross-section. So let's put this all together with some examples. In 2D, we're going to create a profile such as this using a polyline command. And you don't have to draw the exact same thing. Something similar is fine. This is just a good looking shape to demonstrate the command. And close the polyline. And there it is. So it's a nice looking profile that we can now revolve. Now, to start up the revolve command, you can type it in, just revolve and press enter. You can use the cascading menus under Draw, Modeling, Revolve. That's right here. Then you can use the toolbar icons. That's right here. Revolve. That's on the modeling toolbar, and the ribbon you can use the solid tab. Solid. Right here. Revolve. Okay, either way, start up the command. I'll use a toolbar here. We're going to select the object, hit enter, and it's going to ask you for the axis of revolution. For now, we're going to pick, using OSNAPs, the endpoint here and the endpoint here. And you can see that you can move it dynamically to create the revolution, and we can demonstrate that later. There's some use for it, but right now we're just going to hit the default value, 360 degrees, press enter, and the revolution is completed. Now, to see the full effect of what you've done, switch to 3D and shade. So here it is, and here's the shading. And there's our solid. Revolved 360 degrees to create a shape. Extremely useful and versatile command. Now that you've kind of got the basics, actually at this point you may want to just pause the video and try it out on your own. In the meantime, I'm going to show you some variations. I'm going to undo this, and this time I'm going to revolve but I'm going to only revolve it 3/4 of a circle. So axis is still here and here, except instead of 360 I'm going to put in 270. Now going to 3D shaded, take a look what happens. We cut out a section because we only went around 3/4 of a circle. So this is extremely useful for showing the interior workings of a part. Alright, go ahead and try that out. Now here's another variation I want to do for you. Go back to the shape, I'm just undoing. I'm going to do revolve again, this time using a ribbon. Select the shape. Now I'm going to put the axis of revolution not on the object but some distance away from the object, and note the distance I'm using, some random amount, but take note of it. So I'm going to click here and using ortho, here's the other click, and let me also use 270 degrees, and as I switch to 3D, take a look what happened. Our object now has a gap in it, a hole. And that hole is exactly twice the distance that you offset your axis of revolution from the part. Obviously it rotated around that axis, so the hole will be twice as big as that distance. So that is how you create holes in objects. Okay, and one more demonstration has to do with positioning of this axis of revolution. I'm going to do revolve again. Spelling discount. Here it is, revolve, select. I'm going to put the points right here and here. And take a look at what we have here. A completely different shape based on a totally different sets of, set rather, of points that define the axis of revolution. So you can see, aside from the profile, the second most important thing is the axis of revolution, and creates radically different shapes depending on where you locate it. So it's a pretty important concept. Alright, let's do this. I want to show you the dynamic version of it real quick before I move on to the surface of revolution. And for dynamic, I'll go into 3D, do the revolve command again, and specify the axes, or axis. And as you can see, you can do this dynamically. Like many other commands, you see a kind of a pattern here. AutoCAD allows you to do this. And sometimes you may want to do this if it's a random cross section. And you can just click when you're done and shade it. So that is a random positioning. Okay, one more concept that has to do with revolve. I'm now going to explode this polyline and delete one section of it and do the revolve command one more time. Select everything, position the axis of revolution, and select 270 degrees as our degree amount, just for easy viewing. And take a look what we have now once I made it solid, or shaded rather. The shape is no longer solid. It's a surface of revolution, which can be useful in some cases as well. But because it was open, or also because we're using lines instead of polylines, it is now a surface, not a solid of revolution. So a critical difference here, the object is now hollow. So you need to close the shape in order to create a solid. AutoCAD will interpret an open shape as a surface. Alright, so we introduced quite a bit here in this 10 minutes or so of the lesson, so go ahead and practice everything, every version of what I just did, and you'll discover revolve is a very versatile, powerful command, and it's really just limited by your imagination and visualization skills. So go through each example for practice. In the meantime, I'm going to cover one more command in this lesson, and then we'll call it quits till the second one. And this is called shell. So let me go ahead and erase this. And reset back to wireframe. Alright, this one's a a little bit of an easier command. Shell is one of the several AutoCAD commands borrowed from engineering solid modeling software due to their usefulness. The command creates a shell of a predetermined thickness out of a solid object. The shell is of an even thickness all around and can have as many open surfaces as needed. So to demonstrate, let's draw a 10 by 8 by 4 box. So using the rectangle command, we're going to draw a 10 by 8 rectangle, extruded to a height of 4. There it is. And we want to shade it. Okay. And try out the shell command. Now, you don't want to type in shell. That is a OS command, operating system. But you can use other methods, such as cascading menus under Modify Solid Editing Shell. And there it is. And you can also do Solid Tab, Solid Editing on the ribbon. And on the toolbar as well. There's the icon right here. But anyway, we already pressed it, so Solid Edit, select a 3D solid. We're going to select the solid. There it is, it's been selected. Now, which faces do we want to remove? Well, let's create a open box, so I'm going to select the top. And remember, face is this plane here. Click, one found, one removed. Okay, now we can hit enter, because we're done with the faces. And now, how thick is this wall going to be? Well, it can't be too thin or too thick, so let's create, let's see, if this is about maybe 0.25, that should work. Hit enter, and there it is. There's a shell. It carved out, you could say, the box. Very useful. I'm going to demonstrate this one more time. Undo that. And slight variation on it. So here's the shell command. Select the object. Now remove faces. 1, 2. Let's do that. Also 0.25. And see what happened? It carved out both top and front. So very, very useful way of creating open shapes like this. And you'll see this type of command also in other software like CATIA and X Pro Engineer, very popular in solid modeling. Alright, so practice these two commands. You should have already practiced Revolve and now practice Shell. And we'll see in the next lesson. We're going to cover some additional commands. We're going to go right down the list. We're going to cover Taper and Loft, and try to squeeze in Path Extrusion and Sweep. And if we can do that, we'll reserve the third lesson for some examples. And if we don't cover them all, then we'll put one of these commands into the third lesson and then do some examples and get you to practice all this. Alright, we'll see you in the next lesson. Thanks. Bye.